Largest comet ever found shows unexpected signs of activity. The comet's activity is associated with the sublimation of frozen carbon monoxide, which is continuous in time and is not the result of spontaneous outbreaks. Astronomers using the TESS and NEOWISE space telescopes were able to determine the main parameters of the activity of the giant comet C divided by 2014 UN271 Bernardinelli-Bernstein from the Oort cloud. It is assumed that its coma consists of submillimeter-sized grains ejected from the surface of the nucleus during the sublimation of frozen carbon monoxide. Comet Bernardinelli-Bernstein. Comet Bernardinelli-Bernstein was discovered this summer on June 19, 2021, in archival images of the TESS Sky Survey, taken between 2014 and 2018. Initially, scientists believed they had found a dwarf planet. New observations of the object, carried out on June 22, 2021, using the 1-meter Sutherland telescope of the LCOGT ground network, showed that it is active and has a slightly asymmetric coma, which is typical for comets. At the time of the 2014 observations, UN271 was located at a distance of 20.18 astronomical units. The brightness was estimated at 19.8 magnitude, which is slightly higher than predicted. Currently, C divided by 2014 UN271 is believed to be a unique small body in the solar system, a record-breaking giant comet moving from the inner edge of the Oort cloud towards the Sun, which in early 2031 will pass its next perihelion, located between the orbits of Saturn and Uranus. What new information did astronomers find? A group of astronomers led by Tony L. Farnham from the University of Maryland has published the results of an analysis of the TESS Space Telescope's observations of the comet from 2018 to 2020. Previously, TESS images have already helped to reveal the activity of the comet, but now scientists have studied the archival data in more detail in order to determine the properties of the Bernardinelli-Bernstein nucleus. The work also used data from the NEOWISE telescope to estimate the rate of sublimation of substances and the surface of the comet's nucleus. Analysis of TESS images and their comparison with images of inactive Kuiper belt objects and asteroids showed that Bernardinelli-Bernstein showed a faint coma with asymmetry towards the Sun at distances of 23.8 and 21.20 from our star, which makes this comet one of the most distant comets, which showed signs of activity before the passage of perihelion. The comet's activity is associated with the sublimation of frozen carbon monoxide, which is continuous in time and is not the result of spontaneous outbreaks. Conclusions. Scientists have concluded that the C divided by 2014 UN271 coma consists of submillimeter-sized grains ejected from the surface of the nucleus at a speed of several tens of meters per second. The upper limit on the rate of formation of co-molecules in a coma is estimated at 2 by 1028 molecules per second. The comet's activity is expected to increase more and more as it approaches the Sun.